Hi, I'm James Ramsey, Group Product Manager here at GitLab, and this is the Gitaly Group 13.0 kickoff call. I've got a couple of items to share with you today, and the most significant item that I'd like to share is around continued work on high availability for Gitaly. In 13.0, we're hoping to announce and launch generally available support for Gitaly high availability, and this is what we've been working on for many months. We released alpha support in 12.9, and we're hoping to announce a beta in 12.10, and we're continuing to work on it and improve it. And the main areas that we're working on are validating the behavior of automatic failover in our production environments on gitlab.com, and continuing to improve the documentation and address some edge cases that we've identified. But to, I guess, summarize the state of what we hope to launch, the primary things that we're introducing to GitLab compared to today is the introduction of the prefect proxy router, which receives requests from the application and users asking for Git data, and then directs them to the appropriate node within a cluster of Gitaly nodes. So today you would have one Gitaly node for each shard, and with high availability, you can have a cluster of nodes. So if one node goes down, another node will kick in as primary and start servicing requests. And the other important thing to note is that this is eventually consistent. So the writes still are directed to the primary and then asynchronously replicated to secondary nodes. So that means if you've got a backlog of replication jobs that haven't been completed, and the primary goes down, when failover occurs, there will be data loss. This is expected in this initial minimal version of high availability, because in this first iteration, we're favoring availability, because if the primary has gone down and is not able to recover, during that period, we would have to lock the replicas as read-only, which essentially halts most work. It prevents bug fixes being merged to your production code, prevents all kinds of development work. So in most instances, this would be considered an outage because access to up-to-date data has been lost. So we want to favor availability for this first iteration. And this brings me to the second item that I'd like to share with you that we're working on also in the 13.0 release, which is continuing our investigations and experiments with strong consistency. So what we're hoping to launch as generally available is our eventually consistent high availability solution, but we are already working on strong consistency, which means that when you write a commit or create a branch in a Git repository and GitLab returns a success code and says, I've created this branch or I've created this commit, that commit is replicated onto multiple Gitaly nodes at that point in time. So that means as soon as the write is accepted, if a failover occurred, there would not be data loss. And so this is favoring consistency over availability. So we slow down the writes by making it a consistent transaction, but when the write has occurred, it's occurred in multiple places. And this is really where we're aiming for. And we've already done 2 investigations into different approaches. And we've settled on what we think is a good minimal first iteration for us to explore this in a more realistic implementation. And we're going to be using pre-receive hooks to do this. You can read more in the issue description and the previous issues which are linked to learn more about how we've previously investigated. The epic particularly around strong consistency you might find interesting. The other aspect that we're looking at with relation to high availability is horizontally scaling read loads within a shard. So this diagram again, within a shard, there's a primary and multiple secondaries. But if there's a low write volume on a repository, all nodes in the cluster should be consistent. So Gitaly 1, Gitaly 2, Gitaly 3, or whatever you've named each node, will all have identical data with regards to that repository. Today, if you were to read from that shard and ask for repository A or some commit or some sort of information about it, all your requests, read and write, would be directed to the primary, which means you have a heavy load on one node and then almost no load on all your replicas. And so they only see a load when they actually get failed over to and they become the primary and take on all the load. For large repositories, monorepos, in large organizations where you've got thousands of engineers working on the same repository, often a single server can become saturated. So even if you had a dedicated shard just for that primary repository, it's possible to saturate it because no matter how big your server is, it will have finite CPU and memory. And so the idea of horizontally distributing reads across up-to-date replicas means that that load will be distributed better across the available computing resources of the cluster rather than all landing on the primary. So in combination with strong consistency, which means as soon as the write completes, it's on multiple replicas, and this improvement, which is around a minimal sort of iteration to explore this around distributing the reads, I think this shows like the two major areas of improvement we're looking at for high availability, which is strong consistency and horizontally distributing read loads. And importantly, by tackling both of these, this will eliminate the need for NFS in the various configurations that our customers use NFS for replicating data between nodes. So that wraps it up for high availability and the various prongs of our work as we seek to address that. And that brings me to managing large GitLab instances. So again, looking at this diagram, as a GitLab instance grows very large, so GitLab.com is one of the largest instances. We have 50 of these shards, but a number of our customers maybe have 5, 10, 20 shards, depending on their size and scale. The shards can become unbalanced, and that's a problem because you want them to be balanced in terms of storage utilization, and you also want them to be balanced in terms of resource utilization, ideally. And so this is something we want to optimize, particularly for GitLab.com, to make sure that we're delivering great performance to all our customers, but it's also important so that we can simply make sure that there's available storage on the servers and they don't become full. At the moment, we do this through a manual rebalancing process through our API that allows you to move repositories from shard to shard, but we're hoping to automate this. And one of the easiest way to automate rebalancing is to do it when you create the repository. You have to choose a shard to put a new repository on. And at the moment, we have a very simple round robin approach where we just choose any of the enabled shards. But if we were able to weight them, we could, I guess, adjust and distribute things in more useful ways, not just purely based on or off or available storage, but we could use weights that were calculated based on other kinds of resource utilization, like CPU and memory or IOPS on the file system. So our intention to solve this problem is to implement an API for weighting each shard for new repository creation. So you'll be able to provide a weight between 0 and 100, 0 being don't ever put a repository on the shard, and a weight of 100 being the highest possible number. And so we will use those weights and then randomly select in a weighted fashion between the different shards that you've configured. This will be useful for big instances, particularly, and is a really good first step towards automating our rebalancing process. So that's it for Gitaly in 13.0. It's going to be a huge release. There's a lot of really exciting, interesting work happening, and I would encourage you to follow along in the issues and reach out if you've got any questions. Thanks for your time.